Good day everyone, good day grading students. This is Mr. Brian Bulactin again at your service. Welcome back to my YouTube channel. For today's video, I will be making a tutorial for Mathematics 10 Quarter 1 Module 7, which is about geometric series. So there are big questions that we will answer in this video. First one is, what is a geometric series? What are the two types of geometric series? And how are they done? So all those will be learned in this tutorial video. So stay tuned and learn with me. To illustrate geometric series, let's have first this activity. Find the sum of the first 5 terms of the following geometric sequences. For number 1, we have 2, 4, 8, and so on. There are only 3 known terms here, so we need to get or to generate the next 2 terms to complete the 5 terms. First step is you solve for the common ratio r, which is solved by getting the quotient of any 2 consecutive terms in the sequence. So you can have 2 and 4 or 4 and 8. In my case, I'll choose 2 and 4. So to solve for r, it will be equal to 4 divided by 2, which is equal to 2. Now let us complete the first 5 terms now. So 2, copy. 4, then 8. 8 times 2, we have 16. Then 16 times 2 is 32. This time, we will get the sum. So if you say sum, the operation that you will be using is addition. So 2 plus 4 plus 8 plus 16 plus 32 is equal to 2 plus 4 is 6, plus 8, 14, plus 16 is 30, plus 32 is 62. So the sum of the first 5 terms of the given sequence is 62. Now let's proceed to number 2. The given is 100, 50, 25, and so on. Solve for the common ratio r, which is equal to 50 over 100, or you can have 25 over 50. 50 over 100 is reducible by 50. 50 divided by 50 is 1. 100 divided by 50 is 2. So it is equal to 1/2 or 0.5. Go back to the given. So this simply means that you will divide the known terms by 0.5 or divide it by 2. 100 divided by 2 is 50. 50 divided by 2 is 25. Then 25 divided by 2, 100, 50, 25. 25 divided by 2 is 12.5. Then 12.5 divided by 2 is 6.25. Now let us get a sum. To get a sum, you will have 100 plus 50 plus 25 plus 12.5 plus 6.25. Let us get a sum. 100 plus 50 is 150 plus 25, 175 plus 12.5 is 187.5 plus 6.25 is 193.75. So this is the sum of the first 5 terms. What we did a while ago, getting the sum of the terms, this one, getting the sum of the terms is what we call arithmetic series.
The 2 illustrations that I provided you were geometric series. So if you will say geometric series, this refers to the sum of the terms of given geometric sequence. And yes, there are 2 types of geometric series. We have the what we call finite geometric series and infinite geometric series. For the part 1 of this tutorial video, we will be focusing first on finite geometric series.
The first 2 examples that I had given you to illustrate geometric series were easy to solve because we needed only to get the sum of the first 5 terms. There were only 5 terms involved. How about if there will be more than 5 terms involved, like this case? Find the sum of the first 20 terms of 2, 4, and 8. It is very impractical to generate the remaining terms to complete the 20 terms. So in this case, we will be needing geometric series formulas.
And so to facilitate a faster and shorter computation in determining the finite geometric series, here are the formulas that we can use. Formula A, you have S sub n is equal to A sub 1 times the quantity of 1 minus r to the exponent of n over 1 minus r. You're going to use the formula if your r is not equal to 1, where your S sub n is geometric series, A sub 1 is first term, r is common ratio, and n is number of terms. You can use the formula if you are not given the last term. If you are given the last term, or if you would like to solve for the last term, you can use its other form of the formula. S sub n is equal to A sub 1 minus A sub nr over 1 minus r. Again, this is if r is not equal to 1, where S sub n is geometric series, A sub 1 is first term, A sub n is nth term, and r is common ratio. If in case your r is equal to 1, you can use the formula S sub n is equal to n A sub 1, where S sub n is geometric series, n is number of terms, and A sub 1 is first term. S sub n is if in case your r is equal to negative 1, then S sub n is equal to 0. If in case your S sub n, if in case your r is negative 1 and n is even, you can use the formula S sub n is equal to 0. And if r is negative 1 and n is odd, the formula will be S sub n is equal to A sub 1. So there you have it, guys, the 4 important formulas in solving for finite geometric series.
The first 2 examples that I had provided you were that of finite geometric series. Yes, you heard it right. We will be dealing first with finite geometric series. How would you know that it's finite geometric series? When your value of n is given. So let's have more examples for finite geometric series. Let's have this. Find the sum of the first 10 terms of 2, 4, and 8. So, the first step to do here is to solve for your value of r. You need the value of r because that would tell you the best formula among the 4 formulas that I have presented to you to use. So let's start. 2, 4, 8, and then we need to solve for the value of r. r is equal to, just choose any 2 consecutive terms of the sequence. In my case, I will be choosing 2 and 4. So r is equal to 4 divided by 2, which is equal to 2. So, since our r is equal to 2, that means of the formulas I had given you, we will be using formulas A since r there is not equal to 1. So, the formulas that we can use are the following. We can use S of n is equal to A sub 1 times the quantity of 1 minus r to the exponent of n all over 1 minus r. Or you can have S of n is equal to A sub 1 minus A sub n r all over 1 minus r. So these are the formulas in letter A. So you will use these formulas if your r is not equal to 1. So you will use this if your r is not equal to 1. And of course, r which is equal to 2 is not equal to 1. So just choose any of the 2. to help you in determining which of the two can be used, you need to identify the given. So in this case, we have our a sub 1, which is equal to 2, our r, which is equal to 2 also, and what else is given aside from a sub 1 and r? 10 terms. 10 terms correspond to your value of n, which is equal to 10. So our unknown here, our unknown is s sub 10. This is our unknown. So the sum of the 10 terms. Okay? So this time, you need to check which of the formulas has the following given. So let's check with this formula. A sub 1, we have a sub 1. R, we have r. N, we don't have n here. That means we don't have n here, but it has a sub n. So if you will be using this formula, you need to have your nth term or your last term. So there is still a need to have this first before you can solve your s sub n. How about this one? But I would like to clarify that this formula here and this formula here are just the same. So this one is just a more simplified form of the other. Okay? So if we will try this, you have a sub 1, we also have a sub 1 here. R, we have r, and then n is, we also have n, which is 10. So between the two formulas, it is more practical to use this because all the given that we have listed down here are found in the formula. So, proceed to your solution now. For your solution, you can have s sub 10 is equal to, we'll use this formula, a sub 1 is 2 times the quantity of 1 minus r is 2 to the exponent of 10 all over 1 minus 2. Let us simplify it further. This becomes 2 times 1 minus, you have to multiply 2 by itself 10 times. Multiply by itself 10 times, and that is equivalent to 1024. So you will have 2 times the quantity of 1 minus 1024 all over 1 minus 2 is negative 1. So let us simplify this. This becomes, okay, I'll just write the continuation here. This becomes 2 times negative 1023 all over negative 1. So, multiply 2 times negative 1023 is negative 2046 divided by negative, so your final answer will be 2046 positive. So your S sub 10 is 2046. So if you are going to generate all the terms up to the 10th term and you get a sum, you'll get a sum of 2046. Now I will be showing to you the process if you will be using the other formula. If you decide to use this formula. So in this case, again, we don't have a sub n, so the first step is we need to solve for a sub n first. So a sub 10 is equal to, if you remember the formula, it is equal to a sub 1. I'll be writing the formula first. The formula in solving for a sub n. A sub n is equal to a sub 1 r to the exponent of n minus 1. So by substitution, you will have a sub 10 is equal to a sub 1, you have 2. Your r is also equal to 2 to the exponent of 10 minus 1. So your a sub 10 is equal to 2 times 2 to the exponent of 9.
So this is the exponent of 9, which is equal to 2 times 2 to the exponent of 9 is 2 times 2. You multiply 2 by itself 9 times, and it is equal to 2 to the exponent of 9 is equal to 512. And 512 times 2 is 1024. But are we done? We are not yet done because we just solved a sub 10. Now you will now solve using the formula. So S sub 10 is equal to your A sub 1 is 2 minus your A sub n 1024 times your R, which is equal to 2 over 1 minus 2. So this is equal to 2 minus, you have to multiply this first. So you have 8, 4, 0, 2 all over negative 1. So this is equal to 2 minus 2048 is equal to negative 2046 over negative 1. Negative divided by negative is positive 2046 is the value of your S sub 10. So if you are going to generate and complete generated terms, the missing terms, up to the 10th term and get a sum of the terms, you'll get 2046. And you notice that our answer is just the same with the answer, with the previous answer when we use this formula. So that means that whichever of the two formulas you will use, you will still arrive at the same answer, granted that your computation is correct. Now let's have this other example. What is the sum of the first 12 terms of 3 plus 3 plus 3 plus so on? So this is already expressed in geometric series. Actually, to avoid confusion, you can actually rewrite this in sequence form. So 3, 3, 3, and so on. Okay. So just like how we did or how we solved the previous examples, you start solving for your R, because this will help you determine the formula, the perfect formula to use. So R is equal to 3 over 3 is equal to 1. So since your R is equal to 1, therefore, the formula that we can use here is S sub n is equal to n A sub 1. So, identify your given here. Our given are the following. A sub 1 is equal to 3. Your n is equal to 12 terms. 12. So, our solution, let's proceed to this immediately since they are just a 3 all throughout. So you will have S sub 12 is equal to 12 times your A sub 1, which is 3. So the answer is 36. S sub 12. So if you're going to list down all the 3's up to the 12th term and get a sum, it's just like multiplying your 3 with the number of 3's and you'll get 36. So this is the final answer. So the previous formula cannot be used here since our R is equal to 1. Let's have another example. What is the sum of the first 14 terms of 7 plus negative 7 plus 7 plus so on? So we write the given in sequence form. So you have 7, negative 7, 7, and so on. Solve for R again. That would be our first step. So negative 7 divided by 7 is equal to negative 1. So in this case, since our R is negative 1, we have two formulas that we can use. However, in the two formulas, you need to identify your n to help you decide which of the two. Our n here is 14, which is even.
14 is even. Therefore, the formula that we can use here is S sub n is equal to 0. Very simple. So for our solution, you will just write the answer right away. S sub 14, or the sum of the 14 terms, is 0. That's simple. Why 0? If you're going to illustrate that, 7 plus negative 7 plus 7 plus negative 7. So I'll just be making 4 terms because they're also even. Okay? We're talking about even. So 4 is also even. So this is just to show you why 0. 7 plus negative 7, this is 0. 7 plus negative 7 is also 0. So if you're going to add all the zeros, it will give you the sum of 0. So if your n is even and your r is negative 1, automatic, the sum of the terms is 0. Another example, what is the sum of the first 17 terms of negative 5 plus 5 plus negative 5 plus so on? So let us express it in sequence form. So negative 5, 5, negative 5, and so on. Solve for your r. R is equal to 5 over negative 5 is negative 1. Again, your r is negative 1. There are 2 available formulas if your r is negative 1. Therefore, you need to solve, or you need to get the value of your n to help you decide which of the 2. N is equal to 17, which is odd. So since your n is odd and your r is negative 1, we will be using the formula S sub n is equal to a sub 1. So this is your solution. Very simple. Very direct. So S sub 17 is equal to a sub 1. What is our a sub 1? Negative 5. So if you're going to get a sum of all the terms, the 17 terms, the answer will be negative 5. Okay, let me show to you why. I'll just take 5 because 5 is also odd. So negative 5 plus 5 plus negative 5 plus 5. 1, 2, 3, 4 plus negative 5. Okay, let me show you why it is equal to your first term. Okay, you can have this. We're having odd numbers. Okay, odd. So 5 plus negative 5 is 0. 5 plus negative 5 is 0. And then you have negative 5. So negative 5 plus 0 is negative 5. Or if you can have negative 5 plus 5 is 0, you can have this. 0. Negative 5 plus 5 is 0. And then what is left is negative 5. Our negative 5 is equivalent to your first term. So this is equivalent to your first term, right? So very simple. If your r is negative 1 and it is odd, then the formula is S sub n is equal to a sub 1, automatic. And there you have it, guys, finite geometric series. I have presented to you the 4 different formulas for finite geometric series. Again, you would know that it's finite geometric series when you will be given the value of n. So this is just part 1 of the tutorial video for module 7. I will do a separate video for the infinite geometric series. So stay tuned and learn with me. Thank you.